So I got the x plus 3 from this value, I have the x plus 1 from this value, and the x minus 4 from this value, and what I put across the top was the FOILed out or Punnett square version of the output here across the top. Notice 3x plus 1x is 4x. And now I'm going to combine like terms after I multiply them. I got x cubed, these canceled out, negative 13x minus 12. I'm expected to find f of negative 2, and it's supposed to equal negative 24. So let me throw a 2 into these guts. So that's going to be equal parentheses cubed minus 13 parentheses minus 12. I'm going to throw the negative 2 in here and see what happens. That's going to give me negative 8. That's going to give me 26. And that's going to give me minus 12. 26 minus 12 is 14. Negative 8 plus 14 doesn't give me 24. Negative 8 and 14 minus 8 actually gives me 6. So f of negative 2 equals 6. But it wants it to equal negative 24. So what do I have to multiply this by in order for that to equal negative 24? And the answer, I believe, is negative 4. Because negative 4 times 6 equals negative 24. So now I have to take this answer and multiply it by negative 4. So that's going to give me negative 4x cubed plus 52x plus 48. All I did was multiply this whole thing by negative 4. I want to find the possible number of positive real zeros. This is actually kind of nice. All I have to do is ascertain that that's positive, and then do I change sign? I have one sign change. I have two sign changes. It goes from positive to negative. It goes from negative to positive. This goes from positive to negative. That's one sign change, and then it goes from negative to positive. That's two sign changes, and then it goes back to negative again. So the possible number of positive real roots, if these are guesses, is going to be 3 sign changes, and then you step down by 2. Whatever your answer is, you minus 2, you minus 2, you minus 2, until you wind up with either 1 or 0. You can't have negative 1. Possible number of negative real zeros. Now this one's a little tricky. What you're expected to do is throw in a negative 1 and see what your answers are. So negative 1 cubed is negative 1 times 7, so that's going to give me negative 7. Then negative 1 squared is 1, with a negative out front is negative 1. Now I'm not adding these up. 2 times negative 1 is negative 2, negative 6. I'm not adding these up. I would add these up and find some big nice grand prize, whatever. I'm not adding them up. I'm just counting sign changes. And notice there are 0 sign changes. Possible number of non-real complex zeros. Notice it's to the third. So possible number of non-real complex zeros could be at most be 2 or 0. I'm asked to factor this, to factor the polynomial. The deal is it's got a negative out front, so I probably got this one wrong earlier. So immediately I know it's going to have a negative out front. And then I have to factor it. That's negative 8, so that's going to give me x plus 8. This quantity touches in terms at negative 1. Notice the TTs. So that's going to be x plus 2 squared. X minus 3. X plus 2 squared, because it touches in terms, goes through a positive 3, so it's the opposite there. This takes kind of a basic note to get it done rapidly and accurately. So the note would be to know what y equals x looks like. Y equals x squared, up, y equals x cubed, down on the left, up on the right. Y equals x to the fourth, that's going to be up also. Up on the left, up on the right. Same thing over here, y equals negative x is down, up on the left, down on the right. Negative x squared is down, down. So this is a positive 2, x to the 6th. And x to the 6th is going to be a positive up. To graph this equation, it looks really daunting. You'd have to first click on the squiggly button to do the squiggly, it's x cubed. And then you would highlight negative 24. It's got to go through that y-intercept. And then I would modify for it. Once you modify for it, it'll give you the x-intercepts. So I'm going to type in the 1, I'm going to type in the 9, I'm going to type in the 14, and I'm going to type in the negative 24. So I go to 1, I go to negative 4, and negative 6. 1, negative 4, and negative 6. And behavior says it looks like this. It goes down on the left, up on the right. So here it comes, down on the left, up on the right. This one's a little hard, but I can eliminate some of the questions. Notice it goes to positive 216, so it's going to be there. Positive 16 shows up there or there on both pictures. So positive 216. And it's concave up, so it would be a W, not an M. It would be a W, not an M. So I'm just going to deal with these two W's and see which ones I can choose, C or D. So let's see here. It touches in turns. It touches in turns. What I would do, see how it goes through 50 here? I would plug 50 into this equation and see if I got a remainder of 0. So I plug in 7, parentheses 50 to the 4th minus 71, 50 to the 3rd. Notice 50 is the go-to on that. And 396 plus 216. That should all equal 0. If it does, negative 50 is going to be a solution. Factor it, so you have a 0 at negative 6. So that's going to be a parenthesis x minus 6. A solution at 3, so that's going to be x minus 3. Then a solution at 5, that's going to be x minus 5. Find a polynomial, so I'm going to do it in factored form. So that's going to give me x minus 3, so that's going to be x plus 3 squared because it touches in terms. That's going to be 2, so that's going to be x minus 2 squared because I do the opposite of that and the opposite of that. Now I'm kind of sketching on what to do to get it to go down through negative 40. Hey, I would table it. They want me to factor it. Oh, I know it's got to be negative because it goes downhill. That's should be 2 to the 4 squared. Yeah, that's going to be x squared. That's going to be 9 times 4. That's negative 36. That works. Opposite same. The vertical asymptote is x equals 6. The horizontal asymptote is y equals 4. Getting into the asymptote world. It has a range with a gap at 5. So this has a gap at 0. This one has a gap at 5, a gap at 0, a gap at negative 5. It's going to be B. X-axis is a horizontal asymptote. So x-axis and it has a horizontal asymptote going along there. This one has x-axis as a horizontal asymptote. This one has x-axis as a horizontal asymptote. This one has x-axis as a horizontal asymptote. So that's going to be B, C, and D. No A. All right, it has a horizontal asymptote at x equals 5. Let's see if any of those. I'm sorry, it has a vertical asymptote, VUX, at x equals 5. X equals negative 3. It ain't that. The degree of the top is bigger than the degree of the bottom. That means it's going to have an oblique. It's going to have an oblique asymptote. Vertical asymptote, you take the bottom and set it equal to 0. It's going to give me negative 5 halves. There is a vertical asymptote and it's x equals negative 5 halves. Horizontal asymptote. There's a vertical asymptote, it's x equals negative 5 halves. You set the bottom equal to 0 to find the VA. To find the HA, you look at the degree of the top. The degree of the top is 1, the degree of the bottom is 1. When they're the same, it's going to be this coefficient of negative 2 over this coefficient of 2. So negative 2 divided by 2, that's going to be y equals 1. Negative 1 as my horizontal asymptote. You can't have both. You can't have your cake and eat it too. So the deal is, if there's a horizontal, there can't be an oblique. If there's an oblique, there can't be a horizontal. Vertical asymptote, I have to set the bottom equal to 0, so x plus 3 equals 0. That's going to be x equals negative 3 is the vertical asymptote. Horizontal asymptote, notice the degree of the top is larger than the degree of the bottom. There is no horizontal asymptote. Now to find the oblique, you're supposed to do synthetic division. Now there's a little trick for this. In this course, it'll just be x minus 3. But you do synthetic to actually find it. That would be 1, 0x minus 5. I put a 0 there, I get 1, I get negative 3, I get negative 3, and then over here, who cares? You don't need any of that over there. And notice that's going to give me an equation of x minus 3. So the oblique asymptote is x minus 3 for this particular problem.